Hello everyone, welcome to ECE 209 Winter 2021 Labs. Today we are going to perform lab number 2, and lab number 2 is all about circuit theorems. In this lab we will continue using the common electrical tools that we used in the first lab, and we will test some of the um, circuits that are given in the lab manual. So um, you should use the same kit that you've received, um, and you can access the lab manual through eClass. So um, let's see what the lab manual says. Okay, um, so we will be introducing the following concepts. First, we will see what are delta Y transformations. Um, these are simple organization of resistors and how we can transform from one to another. Let me show you. So this is, yeah, you can see that the shape is like Y. The resistors are connected in a way that is similar to Y, and this is quite similar to delta. So this is what's known as delta Y transformation. And then we will look on superposition principle. I believe you must have already covered this in your uh, lectures. And then we will see the experiment. We will experiment the Thevenin's theorem, and then after that Norton's theorem, and then we will find the Thevenin Norton equivalency, and finally we will experiment and see maximum, how we can achieve maximum power transfer. So for this one, you can get your result sheet from this lab to link, and record all your measurements in the sheet, and make sure that you do the experiments, record your results in the result sheet, and same um, does your partner, and then you both can compare your results, and then finally submit one single report. Secondly, we will be using the same waveform software that we used last time, analog discovery 2 that we used previously, breadboard, and all the components that we discussed before. So um, I would encourage you to have a look on the links provided, but I'm sure you must have already covered most of them in your lectures. We can have a small look. So um, as I described before, that there are two common configurations of resistors, and the resistors can be arranged in a delta configuration or Y configuration, and you can also use equations to convert the resistances that you observe at a point. So there are formulas given on the website, and you can go through them and see some of the applications of each configuration. After that, superposition theorem, in which um, you can find out okay, so in this link you can see some of the details provided on superposition theorem. um, and using the superposition theorem we can simply eliminate if we have multiple sources in our circuit, and uh, reduce it to single source. And then Thevenin's theorem. So in Thevenin's theorem, it's very useful when we are analyzing power in a system. We can simply find an equivalent of a circuit at any point, and then the voltage at that point, and we can draw a simple equivalent circuit, so that if we um, uh, would like to modify or do some small modifications in the circuit, it's easier. Like, we will find an equivalent load, we will convert our circuit in an equivalent load, so it becomes easier to analyze. In the Norton's theorem, it's quite similar to Thevenin, but the thing is that we will be focusing on current instead of voltages as we do in the Thevenin. So we will find the current at a specific point in the circuit wherever we are applying the theorem. It's quite similar to the Thevenin's theorem. And finally, we will see how we can use maximum power transfer theorem to find the best load resistance for any circuit. Okay, so let's open the kit and start the experiment. Okay, so let's bring out the components. Get our analog discovery 2 board, all the jumper cables, and the breadboard. Okay, so the first one is delta Y transformations. In the first experiment, we will measure the resistance values of a Y connected resistor network, which is shown in the figure. We will connect the circuit above using the following. Connect a 220 ohm, 470 ohm, and 1 kilo ohm potentiometer as a Y on the breadboard. So you will pick up the correct values and then place them on the board. I will be using some random values. Let's get some resistors. And keep in mind that to measure any resistance, you can always use the digital multimeter. Just to remind you how to measure resistance, you simply need to connect your wires properly to the digital multimeter. So let's first connect the wires. The black one will go into the COM port, and the red one should be connected to the ohms. You can see that we have ohms here, and to measure the resistance, we will move our knob to the second position where you see ohm symbol. right? And now the multimeter will measure resistance. Okay, now to measure the resistance, we can use alligator clips because it'll be easier to grab the resistor. Simply place it like this. So simply connect, and the resistor that I have with me is 1.48 kilo ohms. So have a look on the units and you will find that it's kilo ohms at the moment. Okay, now let's use these resistors to form a Y test circuit. So we have a resistor of 220 ohms, so you will place this 220 ohms resistor on the board. Simply like this. So you need to make sure that you don't place it in the board so that the wires are shorted. Make sure that you use one top row for inserting your one pin, and then you can insert the other pin in the bottom one, right? So now this whole column is connected to this pin, and this whole column is connected to the lower pin. Okay, now we need to connect 470 ohms. So you will measure, you will find a resistor by measuring through DMM with the value 470 ohms, and then connect it on the other end. So make sure that at the lower side your resistors are connected to the same column. So now these two are connected. Now I have to connect a potentiometer. Now the easiest way to do that is simply make sure that the potentiometer, the first pin of the potentiometer enters or is plugged into the same column of the breadboard, like this. So you can see how I've connected all of them in the same column at the bottom, and these are separate. So this is my U, point number U on the figure. This is V, and then W is the center pin of your potentiometer. So we have 3 pins, right? So the center one is simply the W pin as labeled on the website, on the lab manual. You will use the digital multimeter to adjust the potentiometer until you get 321 ohms. So to do that, you will simply remove it from the circuit, and then so since we are using the left side, we will make sure that the resistance between the left and the center is 321 ohms. And you can simply do it like this. Let's connect this to the center, and then use the DMM to see the resistance and rotate the knob until you get 321 ohms. So I'm now at around 321 ohms. Yeah. Oh. Okay, there you go. Once you have set the value, just insert it back into the circuit. So now the center point is W, and it's showing 321 ohms. Now you will use the DMM to measure resistance across the labeled terminals U, V, VW, and WU as mentioned in your lab manual. So to do that, you can simply get some jumper cables, attach them to your alligator clips so that you could measure resistances across terminals. So first is UV. So you will simply connect your one lead to the column where your U is, the first resistor, same one. So simply connect it here like this, and then for V, simply connect it to the other column, and your potentiometer will show the value. Since I'm using random resistors, I have a different value. You should use the values indicated in the lab manual. So in my case, I'm getting around 3.6 kilo ohms. In the same way, you will measure VW. So V is this point, you can keep it there, and W is the center point of your potentiometer. So you will insert the value, the jumper cable, and you see that I'm getting around 2.48 for this case. And then finally WU. So connect this to U and this one to W. Simply enter it to the center, and I get around 1.8 kilo ohms for my case. And if you see, like if I change this potentiometer, I'm getting different values. Okay, so make sure you record all these values, and in the next one you will simply form a delta network using 3 resistors. So I'll just show you how you will be doing that. So let's consider the first resistor. It will be 1 kilo ohm, so you can simply attach it like this. So this is how you're going to attach it, right? Now this is X and this is Y. I'm going to connect the other resistor RB. Again, I'm using random values, so make sure you use the correct value, 680 ohms for RB. Now to connect this to X, you will simply connect it to the same column where your first lead of RC is. This is how you will connect, and then the second lead of this RB should go to the lower part of your breadboard here. Now I will show you how to connect RA. Simply connect this part of your pin to Y, the same column where the other lid of RC is, and then the other lid will go to point Z like this. So this is how your delta connection will look like. Right. Again, you will follow the steps to measure the resistance X, Y, Y, Z, and ZX and record it in your result sheet. Now we will move to the second part, which is the test circuit. So connect the circuit above using the following. Use 1.5 kilo ohm resistor for R1, 680 ohm resistor for R2. For R load, start with a 100 ohm resistor. You will switch out this resistor a few times for another value when required. For power supply, use the positive DC voltage source from the analog discovery tool to set it. Set it to plus 5 volt, but don't enable it yet. Use the wave gen channel 1 W1, the second positive DC voltage source from analog discovery 2 for VB W1. Do not press run yet, but you can configure it in with the following parameters. So type DC and offset will be 3.3. Use voltmeter channels 1 and 2 from the analog discovery to measure all the required voltages: VA, VB, VR1, VR2, and VLOAD. You will have to move the opposite end of the two jumper wires that connect to the channel inputs, that is 1 plus and 1 minus, across the device. You would like to measure one at a time. Okay. And we will use DMM as milliamp meter to measure all the required currents IB, IA, and ILOAD. I have to move the milliamp meter to the appropriate place in the circuit to make the measurement one at a time. So to measure currents at different points, we will break our circuit, introduce our milliamp meter to measure current at each node, and to supply the voltages we will simply use analog discovery board, and to measure voltages we will use again analog discovery board. And you can see that we have two supplies in the circuit, and it's a T shape, or you can say Y shape circuit. So let's build the circuit. Insert the analog discovery tool and connect the cable. Make sure that the orange one of um, this clip is aligned with 1 plus. So you can see this is how we will enter it, plug it. Now I will connect. Okay, now I have plugged in my analog discovery tool. Let's turn on the software waveforms. Okay. Alright, so the waveform is connected. We can see the serial number at the bottom. So it's communicating with the device. Now we will connect our resistors. So first 680 ohms. So you will connect 680 ohms, and then you will use a jumper cable at this point. The reason is so now when we are making the circuits, we need to make sure that our circuit can be easily broken at the node where we have to measure currents. So after connecting 680 ohms, first I have used a cable and then another cable. Let's use proper colors. So red one here, and then the black one at the center. Okay. Now we need to connect 470 ohms. I'm again using a random resistor, and this will be connected to a point here. So again, I'm not connecting it directly to the same column because I need to make sure that I can easily break the circuit to measure the current. So I will be using a bunch of wires to make connections instead. Just use the jumper cables. Now from the black one, I will connect it to the resistor, right? Then this point needs to connect to the other resistor. Which will be the third one. Okay, so now you have your T network. So this is how you will connect it. Of course, there are some more cables that I need to connect. Okay. Now I need to connect V plus to the resistor on the left. Let's use a long cable for that. So V plus here to the resistor, and then I need to connect 2 plus to the same point. I will simply use another cable. Um, 2 plus will be connected in this way. Okay. Now 1 plus will be connected to R1. Let's connect it. 1 plus to R1 like this. And then sorry, W1 was supposed to connect. So I'm just going to change this. W1 to this resistor, and V plus will be connected to R1. So V plus is connected to R1 like this. Okay, now 1 minus will be connected to the other end of R1 here, and ground is connected the bottom. So we are now left with 2 minus. We need to connect 2 minus now. Simply connect it like this to 2 minus, then to the other pin of the upper left resistor, which is R2. Okay, so we are simply connecting VB using W1 from our analog discovery board, and then VA is connected using V plus, and we will switch the wires to measure current at different places. And to measure VR2, we are simply using 2 plus, and for VR1 we are using 1 plus of our analog discovery 2 board. Okay, so once we have this connected, let's set up analog discovery 2. Okay, so according to um, the lab manual, we will set the supplies voltage V plus to 5 volts. Simply change this to 5 volts, but don't enable it yet. Now we'll go back to the welcome window and click on WaveGen, and in the WaveGen we will simply change the type to DC and change the offset to 3.3 volts. 3.3. Okay, once we have it, alright, once we have this, we will enable the supplies. So we will go to supply and enable the master, and in the waveform we will click on the run button. Now once it's running, we will go to the welcome screen, click on the voltmeters and give it a single run. So in our channels we will get the values. So again, I'm using incorrect values of the resistors, so my values would be very different. You will record your values. In this video I'm just trying to show how you will build up the circuit. And program your device. Okay, now okay, so we did not connect our ammeter yet. So let's also connect our ammeter to the circuit, and since we have the wires already, it's easy. You will simply connect this point and the black one to the black clip, and if it's sleeping, just clip on the function button so it starts to measure the current. Okay, now at this moment the current is at AC, so you need to change it to DC. Click on the function button, it will change to DC. Now you will see some current, and again go back to your waveform, click on single run. Now you will get the values. Previously I wasn't getting any value because my digital multimeter was not connected. Now I was getting 5 volts across one channel, so the circuit wasn't complete at that point. Now I have the multimeter connected, the circuit is complete. Now you can take the measurements. So for so for current, I'm currently measuring in this configuration. I'm simply measuring IB. Now I have to measure IA. So suppose if I have to measure IA, I will make small changes in the circuit. Let me show you. So when you want to measure IA, simply remove the two leads. Now before we go to IA, let's break the connection of IA. So we use this yellow lid so that we could easily break it. Let's remove this and connect it to the other resistor so that this circuit is complete at least. Right, and now to measure IA, I will connect the red one to this resistor and the black one to simply this column. Right, so now I will be measuring IA, and make sure like you complete the circuit. Like when you remove the connection for IB, you place the wires, and keep in mind whenever you're measuring current you have to break the circuit, but once you remove your multimeter you have to complete by attaching a wire. So that's why we have to attach the wire, right? So now I can measure this IA, and in the waveform again I will click on a single run and I will get new values. So technically values won't change because I'm just placing my multimeter at different points. I'm not changing anything in the circuit. It's just that I'm measuring current at different points because we don't have 3 different ammeters. If we had, we could directly measure current at different points. Now to measure I load, let's now measure I load, and first remove your ammeter. And to measure I load, I will remove this wire which was connecting to my load. Now the load is no more connected, but I need to connect this circuit. Like now I'm not measuring IA anymore, so I will connect this to the yellow one, right? So now this is complete, this connection is complete, only the load is not connected. I will connect load through my ammeter. So the red one will be connected to the center point, and the black one I will connect this red one to the other point because I want to measure the direction is downwards. The black one will be connected to the center point. So I'm getting now 0.95 milliamps, and again the voltages shouldn't change, so they're again the same values. Alright, so this was a simple test circuit for T, and let's now move ahead. Before moving ahead, we simply need to turn off the voltages before continuing. So we'll go back to waveform, go to supplies, disable master, and also stop all the wave gens. Alright, so we're done with this part. Now we can move to the next one. One more thing to keep in mind, that in the circuit we just made, we were only measuring voltage across R2 and R1. To measure voltages at different points, we will have to remove our voltmeter and connect it to separate points. So suppose currently I'm measuring VR1. If I want to measure V load, I can connect channel number 1 to load, and for that I simply need to remove it. Let me just show you that you will remove channel 1 from R1 and now connect it across. So I will simply remove it from here, 1 plus and 1 minus, and I will connect 1 plus to this row where our load is connected, and 1 minus will be connected to ground. So we need to measure voltage across the R load, and this is how we can measure voltages. So you can measure voltages across different places by using our 2 channels of the analog discovery board. Alright, now we can move to the second part, and in the second one we will be using a similar circuit to study superposition theorem. And you have same circuit, and just follow the steps. And in 2.3.1 VB will be acting alone, so you will remove the supply voltage and simply short it. So for that you will simply remove it. Like if in my case I want to set VA equal to 0, so I will remove it, and I will remove this VA voltage source from the circuit and replace it with a jumper wire to create a short circuit. Now let me show you how to do that. Simply you will so for VA in our case we were using V plus, so I will just remove this V plus, just place it anywhere else, and then I will short this point by connecting a jumper wire here, and then the other one to the ground. So I have multiple locations where I can get the ground. I can simply connect it here. This is a point. where I have the ground pin available. Just make sure you are shorting that point. And so once you have the circuit, you will follow the steps and measure voltages. And then after this, you will perform measurements with VA acting alone. So you will short VB in this case. So we were using W for VB. You will simply remove W and you will connect back VA and you will ground or short VB at this point. So it's simply you will connect a resistor like you will connect the jumper cable like this, one end to the resistor, another to the ground. So once your circuit is ready, simply follow the steps and measure all the voltages. All right, now we will move to the next section in which we will be observing Thevenin and Norton equivalent circuits. So this circuit is quite similar to the previous one, except that we have removed the load. Now what we will do is that we will find Thevenin voltage at the point where the load was. Like if we go back and see, we had a load here, we've just removed it, and after removing the load we will measure voltage at this point. So how we will do that, so as you see, we made a small change when we were doing the last experiment where we removed this voltage source VB. Let's put it back. Here W1 comes to this point. All right, so looks like everything else is in a good shape. So what we can do next is that we will replace our load with an open circuit. Now how to do that? We will simply remove this resistor. Now this is an open circuit and we will measure the voltage at this point. And since we already have our 1 plus connected to this point, it will measure the V voltage already. We also need to remove our ammeter, so we will simply remove this, and since now the circuit is broken, what we can do is we can simply add a jumper cable to complete the circuit. You can do it in several ways. I'm just going to use a jumper cable so it's easy to modify. I'm going to connect this point where I had all the connections from 680 ohm and 1.5 ohm to the center one, because previously I removed it to measure I load. This is completing the circuit. Or what you can do is you can also just remove these cables and you can simply connect this resistor at the center like this, and then another cable, jumper cable, to connect the resistor on the right side, this one, like this. So now blue one is connecting the right resistor to the center point and yellow one is connecting the left 680 ohm to the center point. At the center we have 1 plus connected to measure the voltage. You don't need this 2 plus at this point. You can just remove it. So now W1 is connected as VB. 2 plus, I'm going to remove it. V plus, okay, V plus was removed previously, so I'm going to connect it to 1.5 kilo ohms like this. Okay, looks like everything else is connected properly. We can remove 2 minus, and so we just have 1 plus connected and 1 minus is connected to ground. Okay, all right, let me just give you a closer look of the circuit. Okay, alright, once you have this circuit, you will measure V by following instructions given in your lab manual. So enable both voltage source, we just did it. Sorry, you will use the waveform to enable it. You can see that our waveform was already set, so we have already 3.3 volts. We'll just turn it on, and you will turn on the supply voltage and simply use the voltmeter to measure the voltage, and you will get VTH. Since I'm using wrong resistors, so my values are not correct, you will use if you will use the correct resistors, you will get the correct values. All right, let's go back to the lab manual. After you obtain your Thevenin voltage, just turn off both voltages, as you will continue to use this circuit. So simply just turn off your stop your voltage supply, turn off master, and then we will use the same circuit to measure the current. So we will simply remove our 1 plus and 1 minus, and we will replace it with the ammeter. So just insert your ammeter in between like this, and so this is at the upper point and the black one will go to the lower point, just keeping in mind that this upper portion is not connected with the lower one. So now the circuit is being completed through the ammeter, right? Let's just turn on our ammeter and make sure it's on DC. Currently it's on AC. Let's press the function button once and you will find the current flowing, or I Norton, at this point. And again, my values are incorrect, so don't use them. If you use the correct value resistors, you will get the correct I Norton. Once you have this, finally you will go to the next step. After you obtain your Norton current, just turn off both voltage sources. So in my case, I didn't turn on the voltage source yet. Oh, sorry, yeah, before getting the and before reading the voltage, you must go to waveform and turn on your supplies. Yeah, once you have them, just turn them back off. Let's go to the next step. Alright, finally for the Thevenin we need to determine the resistance at this point. So it's simple. What we need to do is that we will remove the voltage sources that we had in our circuit, VA and VB. So let's do that. Just remove this VB and now VA, and we will short these points. So I will use a cable. This resistor will be shorted to ground like this, and the other one as well. Let's use another jumper cable. This resistor will also be shorted to ground. Alright, now we have the circuit as shown in the Thevenin and Norton resistance circuit figure. Now we have the DMM still connected. We can directly measure the resistance at this point. Simply change your function to resistance and you will get the Thevenin equivalent of your circuit. Again, my values are wrong, so don't use these. If you are using the correct values for your resistors, you will get the correct R Thevenin. So once you have this, you can now implement your Thevenin circuit in the next step. So in 2.4.2 we are going to demonstrate the Thevenin equivalent circuit behaves the same as the test circuit as seen from our load. Connect the circuit below using the equivalent parameters you found in your tests from the previous section. So now we will replace our circuit. Now VTH was determined previously, and RTH is around 470 ohms. That was also determined previously in our last experiment. And so we are going to replace our whole circuit, this one, with simply 470 ohms, because this is the equivalent Thevenin resistance. So what you will do is that you can simply make sure that the voltages are turned off from your waveform software and remove all the wires. Now in this case you will get 470 ohms. Make sure you use DMM or you use the color codes to determine the resistance. Connect your R Thevenin and then your 100 ohms load. I'm just using random values. You can connect them like this. Connect one resistor and then the other one in the upper part, and then other lead can be connected at the lower part of your breadboard. Now we need to supply VTH. We can use V plus. Yeah, use the V plus from our analog discovery tool. Let's connect this thread to V plus. So I've connected this. Yeah. So I will connect this V plus to V plus as VTH. So we'll connect it to RTH, the other lid of the RTH, like this, and then ground at the bottom. So I can use this one to connect to the ground, like this. Goes here. So now I've connected the ground. Now to measure V load, I can use channel number 2. And one thing, so since we will also have to measure the current, so let's make it in the way that it's easy to break our circuit. So I am just removing the resistor, like I was previously connecting them directly. Now I will connect them using a jumper cable. So I was previously connecting them at the same column of the breadboard. Just remove them. I'm now using, I'll now use this jumper cable to connect these two ends, right? So now the current will flow through this jumper cable and then to our load. This is just so that we could simply, when we are going to measure the I load, we can simply place in the ammeter. Okay, now to measure V voltage across RTH, we will use channel number 1. So this channel number 1 will be connected across the RTH. So 1 plus will go at the same point where our voltage is connected, and then 1 minus will be connected, 1 minus will be connected to the other end of RTH, like this. Okay. Alright, now 2 plus. So 2 plus will be connected across our load. So just connect one cable at 2 plus, like this, and the other end will be across our load. So you can simply connect it here, where the one end of your R load is connected, and your 2 minus will be connected to the other end of your R load. So at the bottom side, like this. Okay, since we also need to measure the current, I will break the circuit at this point by simply removing the cable, green jumper cable, and connect the red one at the end of RTH and the black one of the ammeter to the top of our load, right? And I will change our ammeter to milliammeter mode, right? This is how you will build the circuit. Once you have it ready, just keep on following the steps and simply supply the voltage VTH that you measured in the previous steps, and just go to your waveform generator and set the VTH Go to supplies. Since we're using V plus, set your VTH as you measured in the previous step, and then click on master enable. I'm just going to use a random value like 4 volts or whatever. Turn on, and then you will measure current, but make sure it's on DC mode. So click on the function button, and then you will see DC at the top. And using the waveform, you can simply measure voltage. Okay, and again my values are incorrect because I'm not using correct values of resistor, and VTH in my case is also random. Next you will turn off all the sources and then move to the next part, which is Norton circuit. Let's turn off the supplies, and let's move to the next part, which is Norton circuit. So for Norton circuit, you simply have to use a current source instead of a voltage source, and the current source goes in parallel to your R Norton. Now to use the current source, we have a separate device. I'll just bring that one. Alright, so to connect it, you will simply use the IC, current source. Let's remove all the wires we have. So first you will insert the current source in your breadboard. A 20 kilo ohm resistor as R set at pin number 1. So you will use your resistors and find out 20 kilo ohm value and measure it using the digital multimeter. After you have it measured, connect it to pin number 1. So in my case, again, I'm using a random value. You can connect it like this. So this will be your R set. A 24 ohm resistor as R out at pin number 2. The other end of both R set and R out need to get connected together. So suppose you will find 24 ohms value from the resistors you have, and you will connect the out as like this to R out, and then the other end of both the resistors should be connected at the same point. So like this, you will short them. Make sure that this point is not touching, right? So keep them apart, and only the other end should be touching, should be connected at the same column. Okay, now third pin 3 of the device needs to get connected to V plus of the analog discovery. So we will use a supply voltage to simply connect V plus to the N. Okay. Connect the red probe of the DMM configured as milliammeter to the I out point in the diagram above. Connect the black to the V minus pin of the analog discovery 2. So I have this one. So this is my red probe. I will connect it to the I out point, and then the black of my ammeter to V minus pin, which is here. Okay. Next we have a figure of the circuit. Now test the current source by turning on both the positive and negative voltage supplies on the analog discovery 2, and you should get an approximate reading of 8.33 milliamp on the DMM. So you will go to your waveforms and turn on the voltages. Okay, I'm just looking. So you need to change the voltages V plus and V minus until you get the approximate reading of 8.33 milliamps on your digital multimeter. So since I'm not connecting the correct values, I'm not going to turn it on. But you can follow the steps and change voltage and V plus and V minus until you get 8.33 milliamps on the DMM. And then you will measure and record this value on your result sheet. Now that your current source is set up and working, continue by connecting the rest of the circuit. You can use a single 470 ohm as the Norton resistor, as it should fall within the tolerance of the desired resistance before placing the resistor in the circuit, measured using the DMM as an ohm meter. Now once you have these resistors, you will simply connect 470 ohms in parallel. Measure the current I load using the DMM